Hi, everyone. Good afternoon in New York. Thanks for attending this session. So I'll talk about a topic which came up a couple of times here in the conversations about security. And I want to talk a little bit about it, kind of give a background, and provide some of the potential solutions for serverless security. So a little bit about myself. I currently work at Contrast Security. That's my current company. You have my contact here for LinkedIn and Twitter. Previous companies were Akamai, Red Hat, Zerto, and Veracode. And it's kind of a curious history. Really, my adventure in Red Hat started with that little product, which it was before that logo for OpenShift really existed. So it was kind of my first foray. It wasn't serverless back then. We didn't even know what to call it, and it was before OpenShift had container support for it. So it's a very interesting story in the very, very beginning of this journey of figuring out how to run code without spending too much time setting up servers and infrastructure. And kind of the journey continued this thing in the security space. And another product which was very interesting is a product I worked at Akamai, and that product is called Cloudlets. Now let me see, show of hands who have heard about Cloudlets, Akamai Cloudlets. You have, there you go, we have one person. Have you used it?
No.
All right, awesome. Akamai Cloudlets is a product I worked on personally at Akamai. We launched it in the summer of 2014. So it's about an 8-year-old product, still live today, you can use it today. And the idea of the Cloudlets product was really simple. You have your code, there's Akamai Edge, which is of course a CDN, and it runs everywhere on CDN, and code that runs on the edge. Really, really simple. You just write code and it runs, right? And we shipped it in 2014. So that was actually about 5 or 6 months before Lambda shipped. Yeah. Now, I probably give you one of the key reasons why that product, as I said, still alive, it still exists, people still use it for edge redirection and a couple of other things, but a real perspective why this product really never took off. And the first things we did, we had a security review at Akamai, and the security team said, are you insane? You're going to run somebody else's code on our edge servers? That is never going to happen. The code has to be written by our engineering team, and it has to be verified, and it has to be pen tested, and it has to go through a 6 to 9 months development cycle, and through security gateways, and another security, and another security review, and only then it can run on our edge servers. So in a way, security is why Cloudlets, one person in the room here heard about Cloudlets, and kind of everybody else heard about Lambda and Azure Functions and other things. So interesting perspective in history. But as I said, it was a great product in 2014, way ahead of its time. So we're going to really skip this slide because it's really obvious to this audience. It's really popular. Serverless is popular. Why? Because you write the code and it just runs. And what I see across our customer base and across really any enterprise is developers want it because it makes it easy to run faster. So let me dive a little bit in the architecture because that's important conversation to discuss before we jump into the details about security. And again, this was talked about here before. It's really about Lego blocks, right? You take infrastructure, and you take lots of blocks. You take NoSQL and SQL, and you take frameworks, and you take messaging queues and API gateways, and you splice it with your code, and it just runs. And it creates roughly that type of an architecture when you look at it. And the big question is, where do you start and how do you approach it? Well, as I said, great thing about serverless, it's event-driven, right? So you have multiple events, you create a trigger goes to Lambda, and then it operates with those plethora of Lego blocks, right? Really easy to create, really easy to trigger it, and then most of the cases, the code is going to terminate when you finish running. So it starts, runs, stops. Perfect. Now, of course, the problem is that thing is your code, which means if you have any mistakes, any bugs in that code, any vulnerabilities, any glitches, you own it. And there's nothing to protect you before it, and there's nothing to protect you after it. Some security aspects are actually very positive. The fact that it's read-only, the fact that it wipes itself basically, that's awesome. You can't SSH in the runtime. How many vulnerabilities exist because somebody can connect into the runtime of a production server and wreak havoc there, right? And here you can't. Data is mostly temporary. Everything is there. Many of Lambdas, until recently, I had a line there saying you can't really connect directly. You have to go through API gateway. Now, of course, with Lambda URLs, you can connect directly to it, but it's still a relatively new feature. People mostly don't connect directly into Lambdas. In a way, it's kind of isolated. That's a lot of positive on it. But we ran a survey, sorry. We're in a survey, and again, if you look at Contra Security, it's called Contra Security Serverless Security Report, which we published a couple of months ago. And we did a poll between the security and CISOs and other important folks in important companies. And what they want to see is how often have you run into serverless issues. And as you can see here, here's roughly the percentages here. Number one is everything is more than 50%. So out of CISOs that were polled, and it was a pretty big survey. We had a company send out surveys to a whole bunch of security stakeholders. And misconfiguration, insider data problems, ransomware. Oh yeah, there's ransomware for serverless, by the way. You know what it does? It runs crypto mining inside your serverless. You pay for it. They run it. It exists. Denonia recently disclosed. So all of those things basically came out as an issues in serverless security. So yes, it's great. It runs. It's mostly secure, but still we have those issues to review. So how does it happen? What can potentially go wrong? Well, if you have a simple environment, you have a user or you have a endpoint, postman, doesn't make a difference, and you have API gateway Lambda, like the simplest configuration you can think of, it is pretty straightforward. And honestly, I'm sure any of you can easily secure that environment. That is just not a problem. You know what the entry point is, you have an API gateway, and you have a certain spec for the API, you can review it, and you can, probably one person can sit down and secure this type of environment relatively easy. But that's not the real world. Here's the real world. You have user, but user is using voice commands, and they're talking to Echo and Echo goes through skill, and skill goes through the function, stuff like that. And now, what do you test? Where the vulnerability could be, where the attack surface would be. Now it becomes, the connections between those modules become more important than the modules themselves. The Lambda itself is only one piece of that whole puzzle. And what you can do, you can have really what I call surprising emergent behaviors. So for this particular exercise, we have a sample, and one of our security researchers, his name is Tal Melamed, he's also founder of OWASP Serverless. They were able to exploit it with a voice command. They exploited a vulnerability in Lambda code using a voice command. There's a video about it on YouTube, so if you guys want to watch it, it's there. It's, of course, by enough, it's been reported and patched and stuff like that, but the exploit is still there. So I said, user using voice command, not even typing anything in keyboard, can exploit Lambda function. So this emergent behavior really happens from the difference in the architecture, difference in the structure. Before, we had a really nice environment, right? We had a data center, or even if you didn't have a data center, if you were running in a cloud, you had a load balancer, so you had this load balancer. You know where the access points are. You can kind of put a, let's say, web application firewall in front of your solution, and then you kind of wall off the attackers. They can't get inside. They can't get to your instances, right? Well, once you go to serverless, your attacker is going to pick where they're going to fish, and they can fish for any component inside the environment, and they can figure out how to trigger that environment. So how do you solve this problem? Well, kind of two big things here. Number one is zero trust. Never trust any component that you are communicating with. Number two is self-protecting code. And on the permission thing, this is a good example here. Let's say we have a function here. And that function is a pretty reasonable function. You know, it does some stuff, it takes some events, and then it puts in a database. So DynamoDB, one of the most common ones. Now, if you look at the permissions, you have a command here to put item, and it goes to DynamoDB star. Now, as I said, attacker can attack any function they want, any point they want. What do you think is going to happen if they get into that environment and can execute code, let's say exploit some kind of an RCE in that function? They just got into your DynamoDB. They potentially copied all data out of it. Potentially they wiped the database, right? Because the function has start permissions to it. And it can basically do anything you want. So what would be a better solution? Well, better solution would be narrowing down the permissions. So that's kind of the approach where you can take as simple thing as resource-based IAM, we call it, but really a simple concept. If your function, the only thing it does, it works with a database and it puts things in the database, well, your permissions should be put item. If it doesn't read from a database, don't give it permissions to read. Definitely don't give permissions to delete tables, and only one table. Because you know which table you're operating with. So, as I said, that's an example of more complicated setup where you can, as opposed to simple setup where you have only lambda function doing simple stuff, but as I said, if you have a real world application and doing more stuff, you can look at it and say, yep, hey, I'm working with this database, with this table, I'm going to have permissions to put into the table, and that way if somebody gets compromised, you don't escape. That's awesome, right? What if you do it 10 times, 100 times, 1,000 times? How does it scale? What's connected to what? How every developer is going to know what their function is connected to what? Actually, every developer probably knows what their function is connected to. But then the other developers working on the same function can add functionality there, and there's multiple functions and so on and so forth. What's important, where to start, and how to do that. So at this point, we're looking at it as a scale problem, right? As a full application, full service behaving in a real-world environment. So I analyzed a couple of times. There are a couple of ways to look at it, and basically there are a couple of lists. So what you can find is go to OWASP serverless, or you can go to, there's another one list, I think Cloud Security Alliance posts a top 10 or top 12 list. And it says, well, here's the things you should be looking at systematically. So you should look at event injection, broken authentication, and so on and so forth. Overprivileged function, that example I gave you, which is by far, by the way, in my real world, that's by far the most predominant issue that happens in the environments in the world today. Functions are way, way, way overprivileged. They have access to resources which they don't need to. They have access to resources where they don't need the level of access they have to resources. So that's probably one of the most common ones. Vulnerable dependency, I think all of you know about it. You look Log4j. If you didn't have a hell 6 months ago with Log4j, you got really lucky. A lot of people didn't sleep for multiple nights when that happened. Going down the list, denial of wallet. That's actually my favorite one, because there was always denial of service and distributed denial of service. Now we have denial of wallet, where there was a ransomware. There was a tweet from a person who got killed by that ransomware. It attached to their function and basically ran CryptoLocker there. He got a bill for $42,000 from AWS. Yeah. So you get denial of wallet or denial of service, depending how you look at the problem and other things. So let's say, fine, hey, we've been doing application security forever. Why just can't we apply regular tooling? And honestly, I'm standing there outside in this hallway, and people approach me and say, can you just scan my code in the CI/CD? I said, of course I can scan your code in CI/CD. What am I going to find there? So let's talk about case study and what kind of analysis we can do. This is a case study from iRobot. It's publicly posted. You guys have a link there for AWS. It's a solution that they use. And within this environment, you can kind of see multiple aspects, multiple functions, and there is a queue sitting in between, because of course everything runs through a queue these days, right? And you have functions, you have triggers. I mean, overall, it's not a huge application, but it's a very common case, and we see a lot of them, especially from IoT type of devices, where a trigger comes in, and you do put some dev updates, and you put logs, and you create queues, and you operate on those queues. You parse data, put in the databases. It's a very, very common use case here. So again, without going into details of this case, you can kind of see of the path here. And really interesting study to kind of apply it and say, all right, how do you secure this thing? So the easiest one to do is where a lot of people start with. There's a dime a dozen free SCA tools. Dependabot has probably been the most popular of them because free and it sits in GitHub and it gives you results. So it'll give you the SCA software composition analysis results. It will tell you the vulnerable libraries. As you'll find, a lot of Lambda, you actually, especially in some of the simple JavaScript, there's actually not much of the vulnerable libraries. It looks image scanning, and unless you use containers in serverless, you actually don't have images there. So overall, for that particular application, we actually went in and we calculated roughly based how much open source libraries, how much stuff you're going to find. And basically, with this, as I said, we used Dependabot as an example here, you would cover about 10% of the app for iRobot. And you can fix the problems, and that's great for the code that you imported as the libraries and dependencies. But what about your code? What about infrastructure? What about configuration? So didn't really solve the problem. All right, so we did the easiest one. Let's do the next hardest one. It's serverless. It must be IAC. So let's look at the CloudFormations. Or Terraform, if you like. It doesn't make a difference. For this one, we looked at the CloudFormations. So, all right, you can look at the CloudFormations, but now what do you get? You get visibility of what's get deployed. Now you know about your functions. You still didn't cover the code, so you never analyzed what the function actually does, what it does, where the vulnerabilities would be. It doesn't know what logic is in the function. It doesn't know what objects actually connect to each other. It just knows from that example that there's SQS provisioned and DynamoDB provisioned as 3 functions. Doesn't even know where the entry points are because it doesn't know what API connects to. And then again, it is IAC dependent. You just scanned it for AWS because I said I gave that example. If you're going to port it to another environment, Azure Functions or basically any other environment, you have to basically rewrite your scanning and you have to reanalyze from scratch. And depending on different routines, you might not actually find stuff. So IAC doesn't really help you. IAST is super cool, interactive analysis. You orchestrate your code, and it's super accurate. It's super reliable. A spoiler, Counter Security is well known as a leader in IAST, and it's really powerful analysis. And it instruments servers. And in serverless, you don't instrument servers because server doesn't exist. It's serverless, right? So IAST, as good as it is, doesn't work because there's nothing to instrument. You can do DAST. So DAST, a little bit getting a little bit more real. Now we look from outside in. We try to probe the security, and we try to probe that gateway. So, number one is you have no REST or endpoint here. You do have one for the API, but then you hit SQS, and SQS is asynchronous. DAST doesn't do asynchronous. DAST cannot follow out and trigger event, which happens some time later, and then the triggers follow up. So it's going to basically lose itself somewhere in the process. That's roughly what DAST will cover. Doesn't go any further than that. So everything on your right, that's basically missed. And yeah, you tested 2 functions, but that's about it. The old and reliable SAST, we are going to put it in a pipeline. It's going to scan our code, and it's going to break the build if it finds a critical vulnerability. I'll give you a spoiler, there's no critical vulnerabilities in this code. There are lots of holes in it, architectural holes because of serverless architecture. There are no vulnerabilities which SAST can really find here. Because why? What SAST looks for, SQL injections. Show me a SQL injection here, guys. Doesn't exist here, right? So SAST can find it. It doesn't know about infrastructure. So yeah, you can put a SAST scanner inside a pipeline. It's going to scan the code. It's basically going to give you a clean slate here. Because I said for the code itself that runs inside the Lambdas, it just ain't much there. So once we looked at that, we as a company, we said, all right, it got to be a different way there. So a different way, you have to basically look at the serverless to really, really, truly understand the whole picture. And if you don't have a whole picture, you don't have context, you will not get security right. So here's a use case. And again, this is kind of paraphrased Alex's use case, overly simplified. You have a Mario developer on the left, and they are deploying a new gateway. It connects to a function, it does something with storage, something with a function, and it does email, as a simple example here for a fairly simple function with simple usage. But that said, I wanted to make sure that we include the asynchronous part here, so not to make it overly simplified. So here's a path, and what do we want to do? Let's say there is a vulnerability here, and if you get in and you do something bad, question is, can it escape all the way? So what Contrast does is looks at, first of all, it looks at the path. It traces the path. Why do we want to use trace the path? Because we want to actually see which object connects to which other objects. By the way, for that, you kind of have to read the source code and figure out what the code actually does, which stages it follows, which APIs it calls to connect to which point. And if it calls a SQS API or it puts a document in storage and then it gets triggered from S3 bucket, you have to include those things because you have to trace the path even it is asynchronous. All right, cool. And what do we see here? We see that there is actually an injection here in the function triggered by the storage. So if you were used to your conventional tools, you would not pick it up because through the APIs, through the first function and putting stuff in the storage, it doesn't have any vulnerabilities. It takes the code, it just puts it in a bucket. You're all good. The vulnerability is triggered when we pick that object from a bucket. And that's where the problem starts happening, right? Classical remote trigger attack. But it's not classical because it's serverless. And it has this extra hop in it, which makes it really difficult to find. And then what you find is, all right, what does the function have access to? And of course, in many cases, you're going to find that the function has access to way too much stuff that it needs to. Because, as we were talking about at dinner, somebody took a IAM template and copied it over, right? So what you have is you have function. I mean, surely it has access to the storage bucket and email service because that's what it does. But because somebody called IAM, it also has access to the database here. Because just in case you need a database, right? But that database is also the one which runs any all access skills. So you just got all access to all of your users, all the actions that your users do, and yeah, probably not good. So going into what Contrast does. What we basically we basically said, all right, this requires new approach. So what our approach is to look at this problem holistically, really. What we do is we deploy a function in the environment. It's like 3 clicks, and your function is running in the account that you have. In that account, what the function does just has lots of read privileges. That's all it needs. But it has to read privilege to all the resources which you have. And then it analyzes resources, relationship, looks at the code, looks at the policy, looks at everything. And then it analyzes the code first of all. What does the code do? Does the code try to write to the database? If the code never reaches the database, like in my previous example, you probably don't need permissions to that database, right? Or if in early example, I was showing a code which operates with a certain table, well, give you permission to operate with that table, not with all tables in the database. Then it runs, once it sets that analysis up, it actually simulates a couple of attacks. It simulates triggers. So again, if you give it permissions, it will, to do some writes. Now we have to do some writes, obviously. We will simulate triggers, like for example, DynamoDB triggers, SQS triggers. And we'll trigger the functions, see how the function responds, and actually how the system of functions is going to respond to that behavior. If we found something, we'll report it. If not, we'll just continue monitoring. It connects, as I said, it's a function. It runs off triggers. So basically any CloudWatch events, change in the code, change configuration, basically anything that happens there, it will trigger the function. The function is going to go rescan the environment, find what changes, and repeat that loop once over itself. Does it all automatically. And then people say, can you integrate to CI/CD and everything else? Of course you can. You get messages there, as said, either in CI/CD pipelines, or you can get messages in Slack, Teams, or whatever else. You can do emails. So that's basically the idea of the product. And again, what we want to do is build a different product because it is serverless unique product, I gotta say. It's very specific to serverless. It looks at serverless as a holistic program. It takes everything it finds in the context of serverless, and then it analyzes the state of your environment. So that's Contrast. as a lightning talk, sub-lightning talk within my thing, I do ask you to try the tool. So we have a version of the product available for free. It's called CodeSec by Contrast. There are links here. Developer link, or you can get our code from GitHub. And what that thing is, it's basically a command line version of the tool. The main difference is the full version gives you UI and looks at multiple functions. The CLI version looks at one function at a time. It still traces it, what it connects to, but it does just one function at a time. And basically, and I said, if it takes you more than a minute and a half to set it up for the CLI, it's like brew install and npm install. Basically, anybody should be able to do it. You're probably doing something wrong, so ping me and I'll help you with that. But other than that, it's, as I said, you set it up, you configure the CLI, you run contrast lambda, basically same as AWS lambda command, same syntax, and it looks at that function and basically analyzes permissions. I bet you I'd be surprised if this thing does not find anything. Now, I did lose a bet once because somebody actually went and wrote a function with no privileges and was on 3 lines of code, so please don't cheat. So I'll be careful. Now, see, I learned from that. I'm careful right now. I'm not asking to create a function that will not find anything. Do it a real function and see what it finds. And I gotta say, vast majority of the time, oh yeah, the scan takes about 40 seconds, 50 seconds, minute and a half at most. And then, because it does need to scan the code and it needs to pursue all the elements in the chain that the function is accessing. But my point is, as I said, I would be surprised if it doesn't find anything, and by far the most common thing it finds is privileges issues. But as I said, occasionally we found RCs and stuff which is worse than that. So another thing which we're working on, so I talked about AWS primarily. Thanks to our host here of Microsoft, we are working on Azure Functions. So we have a pilot program with a couple of our customers. That is not available yet to the public audience, but I would say probably by the end of summer we'll have Azure Functions version available. It is different because we're so environment specific. The Azure version it does similar things in a very similar context, but it is different. And what we are finding is for every list privilege violation we find on AWS, we're going to find 10 of them on Azure. Just giving you a spoiler. Azure is really good about triggers being way overprivileged. Really, really good about it. So, as I said, coming here, Azure Functions is a very interesting product, and we'll look at other flavors as well. For a couple of other resources, as I said, one of our product founders and our acting CTO of the product, Tal Melamed, is also a founder, one of the founders of Serverless, OWASP Serverless. So he's one of the authors of the Serverless Top 10. Here's links to that. To the Serverless Top 10 project, so the working group basically keeps updated on things that you should be probably looking at serverless, and also they created a product called DVSA. It's on GitHub, and that's DVSA stands for Damn Vulnerable Serverless Application. Please do not run it in production. It is damn vulnerable. But if you have a test environment, dev environment, feel free to get it there, get DVSA, and basically poke at it and see what happens. And that's about it. So I just want to thank you for your time, and enjoy your afternoon, and thank you for being here.